Traditionally, SETI has focused predominantly on radio. Who could forget the movie Contact, where radio astronomy and the detection of a signal of alien origin was a prominent part of the plot. While heavily dramatized, the film gives a hint of what SETI does, but what it doesn't do is show how difficult the process of elimination can be to reduce candidate signals down to something approaching unambiguous. Indeed, no signal we've seen thus far has been even close to unambiguous, but it remains important to keep doing SETI searches. After all, if you don't look, you are guaranteed not to find anything. And in this case, the question of are we alone is one of the biggest we have as humans. This all goes back for more than 70 years, to Giuseppe Cocconi and Philip Morrison's suggestion that aliens might build a huge, enormously powerful radio beacon and scream their existence to the cosmos. Why did they suggest that? Simply because such a beacon, if unlikely, was the one thing in those days we could look for and hope to see if it were there. No such beacon has ever been found, but as SETI progresses, it has become increasingly sensitive and nuanced, looking for ever weaker signals. But also, in addition to radio, there are newer ways that have become technologically feasible for us to search for extraterrestrial intelligence. Indeed, radio is just one potential technosignature out of a number of them today, and there have been all sorts of suggestions as to how aliens might communicate, even to the point of using neutrino communications and other far future technological ideas. Fair enough, we have no idea how aliens would communicate, either with us or internally amongst themselves. All we have to this day is what we can look for. Radio is one of those. But at the same time, radio is like fire. It is a property of nature, and properties of nature are to be reckoned with. They are not technologies, they are not inventions, and as such they do not go obsolete. Radio is no different. Often people will point out rightfully that aliens may at some point no longer use radio for communications, or they will go indetectably quiet as we ourselves are doing with our increasingly sensitive receivers, where the signal strength doesn't have to be wastefully strong in energy. But there are things that probably will never go obsolete for aliens regarding radio, since they are both too useful to not take advantage of, but also because there isn't a better way apparent in nature to do it. Radar is a big one here for radio. By far our most powerful signals we've ever beamed out were radar signals, specifically ones beamed from Arecibo to radar map asteroids. Aliens have a good chance of seeing that if they happen to be looking, though for them it would be a wow signal since those signals did not repeat. But there are other areas beyond radio signals that are extremely useful for communication, and another that may never go obsolete for anyone are optical communications. Basically lasers. Just as light isn't likely to go obsolete for us, neither are lasers, because lasers do what we need them to do very cheaply, and at the fastest possible speed in the universe, the speed of light, for manageable energy costs. And given you are dealing with higher frequencies with lasers in a much tighter beam than you are in radio, that means you can pack more information into your signals. In fact, NASA's work in this area promises 10 to 100 times faster than radio communication with its probes. Laser is the place to go for information-dense transmissions. And communications aren't the only uses for lasers. There are things like deflecting asteroids, pushing light sails, and light sails can leak emissions if it goes off center or the sail moves to an incorrect orientation. And laser is a good way to transmit power from your Dyson swarm collectors back to your home world or wherever you need that energy, which may make for very powerful signals, leaking out indeed. And of course, LiDAR. You can image asteroids and gauge distances much like radar with lasers. Aliens that can build radio telescopes will know of this property of laser light as well, and very well make extensive use of optical communications for their internal messaging, and contacting other civilizations for a number of reasons, not the least of which is laser doesn't expand and degrade as much as radio does, thus less interference. It's more focused, which is not only good for information density, but also distance. Until recently, however, optical SETI was rather limited compared to radio SETI. We have not extensively looked in optical SETI yet, despite it being an inherently useful way to communicate in visible or near visible light. Though we've also only just barely begun looking in radio, even though we've been doing it since the 60s and the late great Frank Drake's Project Ozma. But do remember, there are at the very least 100 billion stars in the Milky Way galaxy alone. It's going to take centuries to look at all of them that we can observe in targeted SETI searches. SETI is a multi-generational effort that may pay off tomorrow, or it may pay off 500 years from now. We simply don't know. But while radio SETI has its intriguing candidates, the WOW signal being one of those, only recently is optical starting to yield some interesting candidates as well, and now there are several new ones. In a paper by Benji Fields and Jason Goodman, link in the description below, they detail several new candidates for an artificial signal in optical SETI. They looked at data on 2,821 stars in the European Southern Observatory's HARPS data for potential candidates. This is an example in science where a data set is taken for one purpose, then archived, and then can be searched by other scientists for a completely different thing, oftentimes years later, such as SETI optical signals. HARPS itself is the high-accuracy radio planet searcher. It's an exoplanet hunter, and in fact is second only to the no longer operational Kepler spacecraft as far as discoveries go. It is a radial velocity spectrograph, and effectively what it does is look for wobbles apparent in spectra, signaling unseen planets tugging on their parent star. But it's a spectrograph nonetheless and can be used to study light from that star system in great detail and potentially pick up artificial optical SETI signals. Bear in mind, all it's needed is if aliens happen to be shining a laser at us. It may not even be intentional. We may just happen to see their own laser communications or laser sails, and so on, effectively leaking to us by chance. As I mentioned, lasers are extremely advantageous for communications, which is why we are making increasing use of laser communications ourselves, in addition to the many other uses for them. But in addition to the other advantages, lasers like artificial radio signals are narrowband in the spectrum. Narrowband signals are a hallmark of technology. Nature only does them under very specific circumstances. You can't easily mistake a laser as something natural, in the same way that narrowband radio transmissions are not something nature does much. Ultimately, nature does not care about wasting energy and thus favors broadband smearing all over the place. But technological civilizations do care about not wasting energy if they can help it. And all they need is a narrowband signal at a known frequency, and they have it. We do this very much ourselves now, and always have. It's why radio stations do not bleed all over the entire dial. This means that the spikes associated with laser signals would stand out against the background thermal spectrum of the host star. This is important. So with a really hot optical light source like a star, the hotter the source is, the more atoms are bouncing around inside it. This causes Doppler broadening of its signal, which makes it very broadband. As all that light, Doppler shifts and interferes and causes everything to smear around in wavelength. This makes narrowband optical signals all the more attractive to look for against the background emissions of a star. The authors used computer algorithms to sift through the dataset and get rid of known sources of interference, such as effects of our own atmosphere that can complicate a search like this, along with cosmic rays to reduce down to a small group of candidates. In the case of cosmic rays, they are very distinctive. They form worm-like tracks in telescope CCD imaging. You can see this signal, which is a cosmic ray, in comparison to this image, which is the detection. They aren't a result of cosmic rays. Other eliminations were things like atmospheric air glow and auroras, which can mimic this, but at very different wavelengths. They were able to eliminate instrument artifacts, specifically bleed-through from the instrument's calibration lamp. They were also able to eliminate human LiDAR satellite interference, and even eliminated special lasers generated by other telescopes nearby for adaptive optics. Again, wrong wavelength. They then worked to eliminate effects like things the star itself was doing, and even some signals of unknown origin relating to the atmosphere which are not really explained, but definitely not of extraterrestrial origin. They were not moving relative to Earth, they were stationary, but hung around for 2 hours stationary, which classified satellites can't do. Those may be of meteorological scientific interest in their own right, because they appear to be mysteries on their own. What happened is that they were working on eliminating sources, and sources showed up in the HARPS data that they were able to constrain down to being in the atmosphere, but did not fit any known interference models. But most importantly here are stellar emission lines. This does not look to be that. The narrow spikes show up in isolation in a way not normal for a star, but work is still being done to eliminate that possibility. The bottom line, however, is that so far 3 signals survived the process of elimination. The first thing to note is that all 3 candidates originate from cool red stars. The authors note that this is a point of caution. While the signals do not look like normal emission lines from such a star, such as seeing multiple spikes during a flare, whereas these are isolated, these cool stars are the worst type for false laser signals of this kind. They are higher metallicity stars, and heavier elements can make narrower emission lines in a spectrum, but not really quite like these signals. These are really narrow. 2 of the signals are from normal M-type red dwarf stars, which are one of the classes of star that is regularly searched in radio SETI. While there is much debate about the habitability of red dwarfs, nothing so far definitively takes them off the table, and when they calm down after their flaring youth, M-dwarfs become the most stable and long-lived type of star in the universe. Aliens could create a colony at one if they are not native to it, and just enjoy trillions of years of stability and stellar longevity. We may someday do this ourselves to escape the increasingly luminous sun that's currently just killing time by being relatively stable before its red giant phase hits. Unlike the red dwarfs, our Type G is actually moving past its period of stability, and in 1 billion years or even less, it will cause the extinction of life on Earth, and in 4.5 billion years, it will probably consume the cinder Earth itself. That's not that long of a time in comparison to the life of an M-dwarf. The final signal was from an oscillating red giant star, CD 312415, not typically the type of star you might expect aliens at, but at the same time, we have no idea what aliens do or do not do, or what stars they find attractive for their purposes. Here it is important to note that this star is near death, and dying stars can do strange things in their death throes. This may be what knocks that star out as a candidate, or of course it could also be a call for help, an SOS, or them sending out the knowledge they gained as a culture as a last testament to themselves. There are reasons to do those things. On the red dwarfs, the first candidate is the exact opposite. HIP 87607 is a very young, very noisy red dwarf. It's a baby, and it's screaming as opposed to a dying star. But here it's a candidate because we see lots of young red dwarfs, and here its stellar activity would be quite outside the norm to account for the detection there. The last is the most perplexing candidate. It's the red dwarf GJ317, and it's an older, quiet, high metallicity red dwarf that's past the wild flaring of extreme youth. And it has gas giant planets, not unlike Jupiter in that system. This means that it could easily have Earth-sized planets we haven't detected, that could be in the tight habitable zone of this star. This is a really fine star system to find another Earth in a stable environment that someone may have colonized, but not a great star system for noise that could throw off this detection. But obviously much more work is needed to take this candidate further. It's also worth noting that while there is debate about red dwarfs, they are not off the table by any means for life to natively arise on their planets. We know that they certainly can, and many do, have planets. But there are also hints from within stellar physics that red dwarfs actually preferentially flare outside of their equatorial zone and more towards the poles, which means the flares of active young red dwarfs would miss the star's planets entirely. Now there's always the chance that these candidates could get knocked out with further work. They are candidates, which means they are worth looking into further, and stars can do some strange things that might throw SETI candidate signal off. But as with anything SETI, you learn from false detections regardless, and you add a new entry for types of interference to watch out for in optical SETI, which is not yet all that well fleshed out. But to speculate for a moment, it's hard to know what we could learn from a laser signal. We'd know it was artificial, and may be able to tease out features, but it's very unlikely we could ever decode it. And not with this data set from HARPS. It's not sensitive to that at all. You need other instruments that can study these signals in a different way if their viability as candidates increases. These signals, if any of the 3 can be confirmed, certainly would do one thing. They would answer the "are we alone" question, Confirming this would mean technological aliens. But even then, we wouldn't share the slightest commonality with an alien as far as how we encrypt data and so on, much less do anything with language if they even have it. But there are other interesting things that a signal might present, and one of them, oddly enough, are timescales. This was brought up in the late 1970s by Frank Drake. We really have no idea what an alien's sense of time would be. They may perceive time much faster than we do, simply by thinking orders of magnitude faster than we do. That would lead to the maximum amount of data being included in signals, presumably, and we might see a fingerprint of that. But also if it were very slowed down, think one data blip at a time, or a very rapid dump nearly all at once. That only happens every 10 years by our reckoning, or longer. We just don't know, but that might actually be evident in the signal and give us a clue as to what this alien species' time frames are like. But regardless, add 3 new candidates to the list of potential signals from alien civilizations. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently noting that I interviewed Benji Fields, the principal author of the paper, over at Event Horizon. Do check it out, link below. But he informs me that another team that was hunting exoplanets heard that interview, and they had worked with GJ317. And they checked their search again and could not rule out an Earth-sized habitable zone planet in that system. There very well may be one there. Fun candidate indeed, and I'll keep everybody updated as new information comes in. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.